The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Welcome and thank you for joining us for this webinar today. I'm Janine Michaels. I'm Marketing Manager here at Redgate. And shortly I'll be handing over to Chris Unwin, who will be presenting today's webinar. Just a couple of things I'd like us to take note of. You are automatically muted. You're probably aware of that already. On the control panel on your dashboard sort of thing, there's an option for questions. Please type your questions in the dashboard panel and we'll make sure to answer those during the Q&A session, which we hope to have some time for around the end of Chris's slides for about 10 to 15 minutes. So with that, I'll hand over to Chris now. Thanks.
Fantastic. Yep. Thank you for that introduction, Janine, and thank you everyone for joining us today. As Janine said, we're going to be taking a look today at how process and the correct tooling can be the sword you need to slay that looming dragon that is worldwide data protection legislation, whether that is SOX, HIPAA, POPI, or even the EU's GDPR. So my name is Chris Unwin. I am the lead on data privacy and protection here in the pre-sales function at Redgate Software. I work with clients from all over the globe to help them put in place not just Redgate tools, but also the mindset that they need to succeed when it comes to data governance. Just a little bit about Redgate then. So Redgate has been around for about 18 years, primarily creating tools for SQL Server developers and DBAs and other people within that world. But recently we've made that soiree into the world of data privacy and protection. And about 91% of the Fortune 100 use our tools. So we've really got that good name backing us there. Firstly, let's start by trying to define DevOps. So I've seen around 101 different presentations, heard 101 different definitions, but I really like Donovan Brown's. Unfortunately, DevOps is not something you can just buy or something you can just decide to do tomorrow. It's a shift that really needs the right guidance to become reality. Data privacy absolutely has a role to play in DevOps, and a successful data governance program can be the key to ensuring that all relevant people and processes are aligned and delivering maximum value to the business without compromising on security. Compliance will, over the coming decade, drive data governance from a technology issue onto board agendas. One of the drivers for this change will be the EU General Data Protection Regulation here in the EU, which becomes enforceable from the 25th of May 2018. But of course, there are so many other legislations to take into account as well. GDPR doesn't just impact on organizations established in the European Union, though. It also affects any organization outside the EU that either offers goods or services or monitors the behavior of EU citizens. In a recent survey run by Redgate, over 500 SQL Server professionals responded and gave us an indication of how they handle the technical and business challenges of data governance in their organizations. I'll briefly cover some of the highlights we found as part of this research. So, survey respondents were from across the globe and represented a wide range of job roles, company sizes, and industries. Among the key findings, we found that around 72% of respondents worked in organizations that were subject to legislation or regulations, such as SOX and HIPAA. Around 64% of respondents said adopting a DevOps approach to their software development was beneficial to their data governance program, and only 5% said it had a negative impact. And of those who indicated that they were running successful or very successful data governance programs, they're using 11 tools on average. And this is in comparison to unsuccessful and very unsuccessful programs which use just 5. So the main drivers for implementing a program were regulation and compliance, and to improve business intelligence and analytics. That was around 44% and 33% respectively. Of those who have implemented a data governance program, around 90% found it successful to some degree, but for those that were unsuccessful or very unsuccessful, the main drivers were to decrease customer risk. Of those that were successful and very successful, 62% implemented some standards or control objectives, and 72% had also adopted a DevOps approach across their software projects and felt DevOps had a positive impact on data governance, and that is unsurprising. So data governance is sometimes seen to conflict with DevOps, as the speed of change associated with DevOps can be seen as a risk. But this couldn't be more wrong. 64% of respondents said a DevOps approach to the database had that positive impact on data governance, and only 5% said it had a negative impact. This is likely because DevOps introduces managed processes that actually simplify compliance by enabling software to be delivered in a consistent, reliable, and repeatable way, and by providing an audit trail of those changes made at every stage. Of those respondents that have a successful or very successful data governance program, around 72% felt a DevOps approach to the database had a positive impact on data governance. We're going to take a quick poll now to see how the attendees today are aligned with some of the other professionals that were quizzed for the survey. So the question is, where does the data in your development, test, or QA environments come from? So we'll give you a few minutes just to fill this in. So pick the one that is most in line with how you work. So a copy of production, typically a backup and restore. That's a modified copy of production, so masked or subsetted, maybe using some sort of tooling or some masking scripts in-house. Generated data, that is automatically synthesized data, and then manually created, going in, typing it out yourself. So we're getting quite a few responses coming in. We'll run that just for a few more seconds. Perfect. Okay. So we'll let that run for 10 more seconds, and that'll be the full minute. The countdown begins. Fantastic. Okay. So let's share those results. So 61% are using a copy of production, 28% a modified copy of production, so masked or subsetted in some way. Around 2% are generating their own data, and around 9% are manually creating data as well. So unsurprisingly, let's move on to the next stage. So if we take a look at some of the respondents that we got from that governance report, again, 61% are using a copy of production. So that is a very, very high level. 44% are obviously using a modified copy of production, around 27% generating data, and around 33% who are using manually created data. So 35% of respondents who were using that data in non-production environments were actually only using a copy of production. This percentage shifted somewhat when filtering by industry. So the lowest percentages we saw were only using a copy of production in non-production environments were in financial services and insurance, about 8%, and healthcare, medical, and pharmaceutical industries, around 11%. And obviously these are the particular industries where we see a lot of governance regulation come into play. As we would expect, the size of organization actually had no significant impact on whether a copy of production was used in a non-production environment. Legislation is all-consuming and will affect every company regardless of size. So today, every aspect of our personal and work lives involves a digital or online interaction that results in the creation, sharing, and storage of our personal or financial information. In everything we do, we leave behind digital footprints about who we are, where we are, what we like or what we dislike. The simple reality is we cannot work, live, or enjoy leisure without giving up data about ourselves. This is the price we pay for all of the benefits of the connected, always-on digital economy. But trust is under increasing assault. In 2017 alone, there were nearly 1,000 data breaches reported worldwide that exposed nearly 2 billion personal or financial data records. This is 160% more than during the same period in 2016, and it's only likely to get worse. Sadly, according to a recent global study by Gemalto, only 1/4 of consumers feel companies take the security of their data seriously. For example, the Uber data breach that occurred in October 2016 and was only reported in 2017. It's just another clear sign that companies are losing the battle to protect their customers' data, and what is at stake is one of the most fundamental aspects of the relationship between consumers and companies, and that's trust. So, how will GDPR and other such regulations impact your software delivery? Well, manual processes impact every stage of software delivery. Whenever we have human intervention, we increase that threshold, that opportunity for risk to creep in. The GDPR specifies that you have a general obligation to implement technical and organizational measures to show that you have considered and integrated data protection into your processing activities, or data protection by design and default. But what does that really mean? Having a reliable and repeatable process in place gives you a great foundation from which to build your own GDPR defensible position, or POPI defensible position. Whether it's tracking changes to the underlying tables in which the data is stored, or monitoring the databases and servers where these tables are stored, DevOps and compliance go hand in hand to ensure that you're able to deliver value to end users and customers without compromising on good data protection practices, or vice versa. So Redgate really sees this as being what we term compliant DevOps, or DevOps with compliance. And we have 4 key steps to achieving that. And Redgate really sees this as being, number 1, where is your data? Discovery. Actively finding, searching out that information as it exists in our data estate. What exactly is our data? Is it sensitive? Is it not sensitive, but sensitive by correlation with other data? And how do we classify that data as such? Who is accessing your data and for what purpose? How do we minimize the actual processing of sensitive data and protect it for only the necessary processes? Finally, how can we demonstrate adequate protection? How can we satisfy audit requirements that we are limiting processing of that data? Well, that first step, obviously, discovery. Now, what we need to do as part of discovery is save time mapping our SQL Server estate to get that understanding, to gain insight into all of our databases. We need to determine where that personally identifiable information, or indeed protected health information, exists. Well, fortunately, as part of Redgate's data privacy solution, we actually have a tool just for that. So SQL Estate Manager, again part of the SQL Data Privacy Suite, provides a window into your SQL Server estate. It allows you to discover and indeed auto-discover SQL servers in all of your domains, to see who has access to what and their permission level. And of course, so much more. Now, discovery is very, very closely paired with classification. What we mean by classification is removing the guesswork, giving that data context and applying the right security levels based on that sensitivity. Well, again, SQL Estate Manager, same with discovery. We can label our servers, our databases, our tables down to a column level if we so wish. We can use Microsoft's own taxonomy and export simple reports based on that. So let's actually jump in and take a look at SQL Estate Manager. So this is the administration pane for SQL Estate Manager. And what we can see if we go straight in is that we have a full list of all of those database engines that exist within our environment. Now, this isn't just the case for seeing these particular machines, but actually what we do to handle these is once we've discovered them, once we know where all of our database engines are, we take proprietary estate snapshots of these. And that can be over the course of a couple of hours, every day if we wish. But these snapshots capture everything from a security point of view all the way down to schematic objects like tables and columns. Let's drill into one of our estate snapshots. So we can see here on the left that we have all of our database engines, analysis services, integration services, everything that we would want to see from a nice high level. And this is what we're getting. We're getting a data catalog, a single window from which to view and manage all of our information. If I drill down further into the specific database engines and indeed the specific databases that we have on all of these different servers, you'll see we have a full list. We can see exactly who owns them when they were created, all of this contextual information about just the databases. But we don't want to see those. We want to see exactly where our information exists. So by drilling in down through the tables, we can actually jump through into columns as well. So you'll see we've got a new snapshot actually has been created here, taken automatically. And if we drill down further into some of those databases, we can actually use the search functionality to actually find particular databases where that information exists. Again, the same can be done, the same searching functionality can be done on tables, and we can actually classify at every single level. So here in this list of databases, I have the Stack Overflow database. Now, this may contain some sensitive information. So by right-clicking on this, I can actually come down and label this. And again, like we said, it's aligned with that Microsoft personal, non-personal, and special taxonomy. I can select this as personal, and then we can actually filter down and pick out any of these particular sensitive environments. And again, that's at any level, so a server level all the way down to column. When an auditor comes along and says, well, hey, where is all of our sensitive information? Not only can we give them a full list of all of our databases, but we can export all of these as PDF, as XLSX, or even as DocX as well. We hand that over and say, there you are, there is a list of all of our information. And that just adds to not only our contextual understanding of all of the information that exists within our SQL Server environment, but it allows us to build that defensible position so that others know that we are putting in place a process. Again, like we say, process is the key to solving all of these problems. Now, as part of SQL Estate Manager, we don't just give you the ability to see down into these schema objects, but we allow you to see some of the best practices associated with security on these machines as well. It could be something as simple as, is SQL Server up to date? Now, if we click into this, we can see that we have an iClone server here, which is on the incorrect version, and it makes a recommendation based on what it believes you should be on. By clicking into the best practices documentation, we can actually go to the Microsoft site and see what backs up the reason for this. So again, we're seeing both the initial value that SQL Estate Manager offers, which is to be able to discover and initially classify all of that information, but also ongoing. As our environments change, as security settings change, we take ongoing snapshots and constantly tune and perfect our security settings and also the way we're tracking our data. Now we can generate reports based on this. We can see what we have as labeled, we can see the DB size, we can see log size, and we can set up all of our own reports as well. Now we can set up subscriptions and alerts based on any of these objects, and ultimately we can be alerted to changes. If we have a look at some of our estate snapshots, you'll see that we have a differences detected column as well. Now we can actually compare these snapshots and see what's changing. So if in 4 hours someone's added a new column to one of our tables and that has made its way up to production, and we take a snapshot of that, we can then compare them and say, someone's added a new column. I'm going to go in, I'm going to classify that, and I'm going to use this to further drive my contextual understanding of the data. We can leave comments against anything from a snapshot level all the way down to particular databases that exist on that server as well. So it works very much as a collaborative tool so that everyone is able to share information between them and able to work. And all of these labels, all of these comments, all of these tags will persist between snapshots. So that's Estate Manager in a nutshell, something that will allow us to not only have a single pane of glass to see everything that exists on our environment, but also to track what's changing, to see what security settings we have, why they're being changed, and if it's aligned with Microsoft's recommendation. So without further ado, moving forwards, let's see what the next part of that cycle is. So we've discovered our environments. We've classified what's important to us and why it's sensitive. But the next step in that wheel is, of course, to protect information. Now, protecting isn't the easiest thing to do. We've got lots of things to bear in mind. We have to safeguard against data breaches and unauthorized access. We've got to automatically apply masking rules when provisioning new databases for software development processes. And we have to ensure our business critical data is safe at every stage. Now, fortunately, as part of Redgate's SQL Data Privacy Suite, we do get tools just for that job. SQL Provision, or the combination of our data masking tool and SQL Clone, allows us to replace sensitive data. It allows us to create SQL Server database copies in an instant without worrying about that same footprint in terms of space or time. And then with SQL Backup, we're able to have, again, a single pane of glass, something that allows us to manage all of our backups, something that allows us to protect that strongly with 256-bit AES encryption and to put that wherever we need it, whether it's on the network or even up into an S3 bucket. So the combination of these tools really lead to the opportunity to protect all of that information. So let's jump back in and have a look at some of this software in action. Now, protecting our data isn't always the easiest thing to do. I here have a forums-redgate.com dev environment. Now, I want to enable my team to be able to work on copies of production so that we can enable their workflow to allow them to test on more realistic information and to deliver value faster. But the problem with this being a backup and restored copy is that not only is it taking up a huge amount of space to do that for every dev and test and QA environment I want to create, but it's also taking up my time to create those environments. Also, as part of this backup and restore process, we're not taking into account something that is absolutely critical in the world we're in today. And that is the sensitive information. You'll recognize some familiar names here in Grant Fritchie and Steve Jones. And these are all people who need to be protected. If I knew my details were being copied into a dev and test workflow, which isn't necessarily as secure as a production environment, well, it would be concerning. So the way we're going to protect that particular information, whilst at the same time delivering value to our development teams, is through a combination of components. The first of those is our data masker for SQL Server, that first component within SQL provision. Data masker actively masks all of that information statically, physically replacing it with anonymized but realistic data such that it can't be reverse engineered to get back to the original data subjects. Now, Data Masker for SQL Server outputs what we call a .dms mask set, a file that can then be fed into that cloning component of SQL provision, which we'll talk about in a moment. But we can also use the component on its own to mask data where it sits. You'll see here that I have a number of rules in my set already. So in very Blue Peter style, this is one I created earlier. And you'll see that we have a substitution rule and a row internal synchronization rule, but more on those in a second. We also have a controller literally storing information about the schema of the database that's going to be masked. And typically where people have had their own masking scripts in-house, they have struggled to maintain these through whatever overhead that creates. And it's the foreign key relationships, it's the indexes, it's the row counts and the triggers, all of these things that make those particular scripts hard to maintain. Well, in the data masking component, it's as simple as pressing a button. And we can update all of that schematic information by default. Now, before we carry on looking at some of these rules, it's important to bear in mind that there is more information present in the masking component than meets the eye. If we have a look at the rule statistics tab, you'll notice that we have the option to see how many rows we're going to process with each rule. Not only do we get information about how fast the tool is running, how performant it is, but we also get to see exactly how we're protecting that information. If we have 500 rows in a contacts table, then we want to know that all 500 are being protected, again, by design and by default. The masking tool itself is a multi-threaded process so that we can concurrently mask different points within the same database. Now, we get around creating a deadlock condition with rule dependencies, which we'll see shortly. But that just allows it to use up to 16 workers at any given time so that we can completely anonymize all of the data that's relevant for us. Finally, Redgate gives you over 100 pre-populated what we call data sets for you to use, whether that's bank account numbers in the Netherlands, down to countries, credit card numbers, date offsetting, names, all of this information, but we do also allow you to define your own sets as well. So here you'll see I've got SLDs or second level domains. Now this I populated in the back end of the tool myself. It took all of about 3 seconds, and all this does is allows me to define .example.net, .invalid, .test, all of these useful second level domains that I can use to create realistic email addresses. Now you'll see down here we have also the directories where we'll be writing logs and reports to, and where we save all of our data and masking sets as well. Now we've picked up on that last report directory as well. Where are reports being written for this tool, and what do the reports contain? Well, fortunately they contain the rule statistics. They tell us how many rows of data we have in each of these tables, and then also how many rows we've processed. And that allows us to catch any sensitive data that might in fact be moving into pre-production. So again, very much our due diligence. So in our rules in set, you'll notice that we have a substitution rule. Now, there are a number of different ways that we can protect information with the data masking component, whether that be a substitution rule, literally taking one value as it exists, replacing it with another so that it can't be reverse engineered, whether it's shuffling information between rows. Maybe it's not directly sensitive information, but you want to preserve a certain spread of values. Or maybe it's an insertion rule. We want to be able to insert brand new generated data as well that's in line with data that already exists. Now, we've used a substitution rule in this particular rule set to protect the information in that contacts table. You'll see that we've got a very straightforward column to dataset mapping, that is contact full name, and we're generating names first and last for male and female. We're then generating some work and mobile numbers, and also some realistic addresses as well by use of a correlated data set. So when we specify that we want a town and that ends up being Cambridge, we might end up also with a postcode that starts CB. After we do that substitution rule, you'll notice that there's a little indentation here for the row internal rule, and that is that rule dependency that we were talking about. This makes sure that the substitution rule runs before the next operation can actually start. And that prevents us hitting that deadlock condition. If we take a look at that row internal rule, what we'll notice is that actually we're taking masked values as they appear in first name and last name, and we're taking them and appending them to some data masker parameters, in this case random dictionary words and those second level domains we just saw. And this allows us to retain realistic email addresses. So if Chris Unwin becomes Tom Smith, then Tom Smith should get tom.smith@window or happiness.localhost.example.com. Something that looks realistic, but ultimately will not get you back to the original data subject. There are absolutely other synchronization rules present in the tool that allows us to synchronize even between tables so that we can retain the integrity. But for the purposes of today, that isn't going to be a problem. So we'll stick with these two rules. Now, we've seen how we define those rules for taking our pre-production environments and anonymizing them such that we can still enable a good DevOps process, but also in such a way that it is physically lifted out of the scope of the GDPR or POPI or HIPAA or SOX or any such legislation. But how then do we disseminate that to the teams? How exactly do we share this information with our development teams to enable that DevOps process? Well, it's very easy indeed. We give this data masker set to SQL Clone. Now, SQL Clone, as part of the data privacy suite and indeed as part of SQL Provision, allows us to create what we call a SQL Clone image. And from that image, we create clones, literally differencing disks that reference that image. Now, the images themselves are fixed point-in-time representations of a SQL Server database that are taken from either a SQL Server database or from a backup. And now what that means is when we spin up these differencing disks on hosts to use, for example, our development servers or from our test servers or to even our developer machines, it means that we're able to physically apply a masking script to the image and protect it. Then it's put onto a Windows file share. And from there, these clone differencing disks essentially become what we work on. They're delivered to those SQL Server instances. And because they're only differencing disks, they're very, very small. And because they're very, very small, they're very, very quick to be delivered as well. If I go to create an image and we go instead from a live SQL Server, we're going to choose our Win 2016 server and our forums-redgate.com dev environment. Remember, it was a full backup and restore with all that sensitive information in, and that's what we want to get away from. So I can go ahead and drop in that masking set we just created, the one to protect all of those contacts. But if I want, I can also drag in and drop SQL scripts as well. So if I need to remove production users and instead apply dev test users, that's absolutely something that we can achieve. For now, though, I'm just going to choose my forums-redgate-com masking set. And we can choose what order they run in. As I've only got one file, we'll just run the one. I hit continue and choose that file share where we're going to be delivering the image. And then we give it a realistic name. So I'm going to go with forums, Redgate, and it's a production copy. So there's our image name. So we create that, and what you'll see is it gradually mounts that disk image, checks the permissions, creates the shadow copy, and restores a copy of that database, masking it as it goes into that SQL clone image. Then it's finalized on the Windows file share, and you'll see we've got this modified flag set to show that it's been protected. From an auditing point of view, we can see exactly who created it. I'm logged in as Redgate. We can see exactly when it was created, where it's located. So we can track where all of our data is going. Now, because we've protected it with that masking set, it's not so important, but at least we get all of the information we need to prove that we're doing everything from our side. I can now create, cut down incredibly lightweight clones. So if we say next and give it a realistic name, so forums_dev_clone, I can create myself a cloned dev environment, or indeed several development environments. Now, the clone itself is around 46.1 megabytes. And even if forums-redgate.com prod as an image was 104 gigabytes or 10.4 terabytes, the clone would still only be several dozen megabytes on creation because it's referencing that image. So we're not duplicating our data, but we're also protecting it as well. If I come into SQL Server Management Studio and refresh all of those databases, you'll see that we have our forums dev clone, and we can work on this like any normal copy of a database. And although it's only 50 or so megabytes in size, we still have access to all of that data. But in the case with this particular clone, you'll see that it's consumed that masking set and protected all of our data subjects inherently. It's given them realistic names, it's given them realistic numbers, and indeed realistic emails as well. And that's how we go about protecting the information that we send into pre-production. This whole process can be completely automated, and the maintenance of those masking rules as we move forward is very easy indeed. Now, we've taken a look at everything we can do for pre-production environments. Also, previously with classification and discovery, we've seen how we can know where everything is and how sensitive it is. But there are other avenues coming out of production that are incredibly important to bear in mind too. And as part of that same protection, we want to make sure that we're backing them up efficiently and securely. Here we have SQL Backup, again, part of that SQL Data Privacy Suite from Redgate, something that allows us to have, again, a single pane of glass, something from which to manage everything. With SQL Backup, we can specify new backups and actually define meaningful retention policies for this information as well. So whilst some databases might contain sensitive information and therefore should only have retention policies of, say, 15 or 30 days, other databases might contain headless financial information that isn't sensitive in any way, and therefore we could hold on to that for slightly longer. All of this can be specified with SQL Backup. We can choose when to delete it, if we can overwrite it, and of course how we're going to protect it as well. So that is the protection stage of Redgate's data privacy solution. But what was that final step in the wheel? Well, the final step was monitoring. What we want to be able to do is proactively monitor your data estate, prove compliance, and be alerted to incidents. Now, it's important to note at this point that monitoring isn't just a step, it isn't just the final step in that wheel. It's actually something that encircles the entire process. Now, the availability of our data is actually incredibly important, and we want to make sure that all of our servers are behaving and responding as we would like them to, as loss of availability of our own data could indeed constitute a data breach. Well, fortunately, with the combination of SQL Estate Manager and SQL Monitor as part of the data privacy suite from Redgate, we can automatically generate reports. We can track changes with snapshots and check user access permissions. Ultimately, we get to monitor that availability of these servers and databases. Now, SQL Monitor is, just as it says on the tin, it's an important tool that gives us a nice high-level overview of exactly what's happening on each of our servers at any given time. Now, that's not to say all it does is give you that high-level view. We can actually drill down both from a high level to a really, really low level and see everything that's happening on any of these given servers, whether we're looking at some of the key metrics like CPU, memory, disk I/O, and weights, or whether we want to see further information about the machines or about the databases that exist on those servers. We can actually go back in time to view particular parts of the graph where we were experiencing high CPU or high disk I/O, and we can change the metrics below the graph to reflect that. And this allows us to proactively check and align ourselves with what's happening on our servers to make sure that any downtime is avoided and is taken care of moving forwards. Now, SQL Monitor actively alerts us, as you can see represented here on this graph, as to what sorts of issues we're facing, whether they're long-running queries or deadlocks. And this alerting, this proactive alerting, allows us to respond to problems as they happen. I can send emails to all of the relevant people saying, we've lost availability of this particular database. And that allows me to treat it with the urgency it deserves, especially when that contains personally identifiable information. Now, we can drill down into more of this, but ultimately what we can do is generate reports. And reports come with that same go back in time functionality to see exactly how each of our instances have been performing over the last 3, 7, 14 days, whatever kind of time period that you're looking to have a report for. And again, if an auditor comes along, you've got that single pane of glass from which to manage everything. You've got the ability to output reports saying, well, yes, over the last 7 days, actually, SM Dev 1, Dev 2, and Dev 1 have both had a little bit of downtime. Do they contain personally identifiable information? No? Okay, well, that's not such a problem, but we will still get to that performance tuning. So we can see at exactly every level how we should be treating this, how we should be responding to issues, and then, of course, proving to others that we're doing our due diligence, proving to others that we're enabling those instances to have full uptime. And we can export all of these reports. That's absolutely not a problem. We can save that down as a PDF and copy it across to anyone who's interested. And like I said, the whole process is iterative. It spins and goes around. We discover and we classify our information. Then we protect it and monitor the whole process, but then the journey begins again. And whilst we continuously monitor, we discover any new tables or columns that are added to our estate. We classify them as whether or not they are sensitive information. Then we protect them by either updating our masking rules or changing the retention policies on those backups. And then again, the whole process continues. So ultimately, what we've seen is using Redgate's SQL Data Privacy Suite and indeed the guidance from Redgate, we can stay compliant and use production-like data. We can actively enable a DevOps process because the two feed off of each other like cogs. Now, when good DevOps is turning, when it's repeatable, reliable, flexible, and doesn't have that much manual intervention, compliance is also satisfied, and vice versa. By creating a consentful processing boundary, we actively enable only the data that we need to be processed. And it's almost like a data firewall. So Redgate actually has a SQL Privacy Summit coming up in London on the 18th of May. This is going to be an exclusive conference for data professionals. At the event, some of the topics covered today will be covered in a bit more detail, and you'll get the chance to network with fellow professionals and get advice from industry experts. If you're interested in attending, you can register using the URL on the screen, which is www.red-gate.com/discount, and you'll be able to benefit from a 15% discount from the ticket price. And if you have any colleagues who want to join the event, then choose a special group discount rate, which is for 2 or more attendees. So let's move on to the question and answer session. We've still got some time left, so if you do have any questions, please feel free to type those into that chat window, as Janine said at the beginning. And what we'll do is try and tackle those as we go through. So let me just open this up. So the first question I'm reading is, how do we deal with freehand text in Data Masker? So if it's stored in a column that has been put in by a human. That's a great question. Now, it's not the easiest thing to do, largely because you could search and replace information in that column. So if it exists as 555-123 as a phone number, then it's slightly easier to find, but you never know how people are going to type that in. They could type it in with letters, for example. Now, the easiest way to protect that information is to either null the column out by default, or it's to put in lorem ipsum as a boilerplate text, or even to potentially take a subset, maybe 100 or 200 columns of rows of information that you expect to be in there, sensitize it or desensitize it yourself, and then use that as a user-defined masking set. So ultimately, it's up to the process that you want to adopt. Now, we do have another question. So what are the difference between these tools and the built-in functionalities like TDE, encryption, etc.? So the difference is that TDE and encryption, obviously, they're specifically designed for obviously keeping control over that production database, but ultimately what we're providing is the static masking of information to prevent duplication, even when we put that into pre-production environments. It's not always a hacker breaking in who takes that information away, but often sometimes it's our own people as well who accidentally release some of that information out into the wider world. And you can absolutely, even if you have TDE enabled on a database and you want to take a clone from it, then absolutely you can. There's definitely ways of working around that particular thing. So the next question is, Net 2000 offered Data Masker for both SQL and Oracle. Is Redgate continuing to offer both? Yes, absolutely. We are still offering both. In fact, version 6 has fairly recently been released, and we have put an entire team working on those tools. We definitely see them as part of our strong solution in both areas. So why not create user-defined data types and apply the rules to the UDT and then apply them to application columns? I'm very sorry, can't answer the question right now. What I'll be able to do is chase that one up, and we'll be able to come back to you directly. We'll take a print of all of the information in these questions, even if we can't answer any of them or all of them, and we'll come back to you directly. So can the masking and cloning tools be run as command line? Yes, absolutely. With SQL Clone, we provide PowerShell commandlets that you can use to automate the masking and provisioning of environments. So that would be set to run maybe overnight or over the weekend, however you want it to work. And the data masking component on its own also has that command line hook in as well, so you can use that to protect information on the fly. So how can we search for sensitive data if it is saved in a column that is named generic? That's a really great question. So at the moment, Redgate are working on delivering functionality to Estate Manager that will allow us to better understand some of the data contained in those columns when we're obviously looking for personally identifiable information. At the moment, that is just down to our own understanding of the data, though. Following that is, how does the Privacy Suite identify PII data, and if so, what is the precision? So what we have is some new functionality that will be delivered in only the coming weeks, and what this will do is try to read all of that, all of the different column names from your database and start suggesting ways that that could be classified and what sort of information it might contain. So absolutely keep your eyes open for the next release of SQL Estate Manager, as that will be something that you'll be able to take advantage of. So another question, does the suite allow real-time encryption of PII that can be decrypted when needed? My question there would be, why would you need to encrypt information that had been desensitized? Or if you did want to encrypt information, then it could be encrypted potentially after you've already run that masking process. So another question, can you create a SQL clone off of a read-only replica in an availability group? Not 100% sure of on the read-only, but definitely it is possible to create a clone, well, to create a SQL clone image from an availability group. If you pass it the backup of an availability group, then it will obviously use the primary node to create that image, and then you'll be able to create clones from that. So another really great question, can we monitor which data or databases have been masked using Data Masker for SQL Server? So at the moment, no, but what's happening is Redgate are building in integrations between the two. It's very much on the roadmap, so that we'll be able to surface information into things like SQL Monitor to say whether or not a database contains personally identifiable information, and of course if it's been masked using SQL Masker as well. So is the Estate Manager available outside of the complete privacy bundle? No, it is a tool that's only present in that SQL Data Privacy Suite, because we see its value very much as feeding in that understanding to the other tools as to how we're protecting those environments and just keeping that whole process going, that flow through from discover to classify to protect to monitor. So is there overhead when accessing masked data from a web application? Not 100% sure on this question. Obviously, once the data has been masked, it's been statically masked into either a clone or a standalone database. So the same process will happen whether you were connecting to a database with PII in it or one that had been masked. So we've also got another one. Masking data is the same across all databases. For example, address one database is masked, another database with the same address gets masked. Would the end result masking data be the same? Okay, so this is more about synchronizing. So if we had two databases where in the first database we had a bunch of names and addresses that we needed to mask, and we needed to reflect those same changes in another database, then it's absolutely possible to do that with the masking component. So once we run through the masking of that first database, we can then use a table-to-table rule across database to then synchronize down based on a common join key, so something like customer ID. But yes, that's absolutely possible.
Okay, Chris, I think, do you have any more questions? I don't think we have any more coming up. Oh, there's some more coming through, sorry. Do you want to take that from James Paget?
Yep, absolutely. So is there any tool in the suite that can encrypt or mask data at the production level? So technically, the masking component, data masker for SQL Server, can still be pointed at a production database. So you could theoretically use where clauses within the tool itself to identify only lines of information where someone had forgotten to be, had asked to be forgotten from the system, for example, and include only that customer ID in the where clause. So yes, absolutely, it can still mask data at the production level if that's what you need, but obviously it is very dangerous to be going in and masking that information, and it depends entirely on your process.
Another one in here.
So one final question then, if we have a production database size of 1 terabyte, how long will it take in time? Will it be very slow? Well, actually 1 terabyte is one of the lower limits of our SQL provision package with clone and masking. Actually, it shouldn't take too long at all, but again, it entirely depends on your setup, how long, what the actual network linkages are there, and exactly what hardware you have in-house. Cool. So I think that's all the time we have for today. Let's just pop up the final slide here. So if you do want to follow up with any particular information afterwards, or if you have any following questions, please feel free to contact us at dataprivacyprotect@red-gate.com, or discover more on our solution pages at www.red-gate.com/solutions. And what we'll do is obviously do our best to follow up with yourselves, make sure all questions have been answered, and that you get obviously everything you need from Redgate. But apart from that, thank you for joining us for today, and have a great rest of the week.